Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Welcome to another episode of Lost in Science. It is roughly half an hour-ish of science on your listening device, where it is with me, Chris, and my erstwhile colleague. Erstwhile, is that correct? I don't know. I'm going to need to look up the dictionary for that one. Stu. How are you, Stu?
I'm very well, Chris. How are you?
Good, good. I had just somebody said that and had a vague suspicion that erstwhile means something bad. But I shall. If it means something bad, I don't mean it, Stu.
Well, thanks for that. I don't think it's a big problem. Erstwhile is fine. I'm sure it can't be too offensive.
No. Look, we both have some, whatever we are, offensive or not, we both have some excellent science this week. I am going to be speaking to a famous climatologist, Professor Michael Mann, from the University of Pennsylvania, who is coming to Australia next year. You'll be able to see him speak. But we had a bit of a chat to him about climate science. Michael Mann is probably most famous for the hockey stick graph you may have heard of.
Yeah. Well, it's a pretty old graph now, but yeah, it's been controversial over the years.
It has indeed. And it basically shows how the current warming that we're seeing is unprecedented. So we had a bit of a chat about that and about what is being done and not being done in the world to take action on climate change.
Well, that sounds really interesting. I'm going to be talking about it will have passed by the time this goes to air, but the 5th of December is World Soil Day. Did you know that?
Oh, no, I did not know that. Time to get dirty, I guess.
Yeah. And I have to point out that, we do have to think about soil as not being the same thing as dirt. Soil only becomes dirt when it gets on your clothes or on your hands. The soil is a very important thing. But yeah, so since 2002, there has been an annual World Soil Day to focus people's thoughts on soil because it's a pretty important thing. And the theme this year is soils where food begins, which is a pretty important aspect of soil. And I'm going to just talk a little bit about why is soil important, how it kind of gets classified, and also a little bit about the CSIRO's launching a website all about soils, which will be coming up later on. But I'll talk a little bit about that later on in the show too.
Excellent. Sounds like a top story idea there, Stu. No, I'm trying to think of a soil joke that isn't dirt related since you ruined that. But look, it is quite an earthy subject, I guess.
Get the dirt on soil. Yeah,
that's right. Guess right. Can you dig it? All right. Well, we'll all be digging that later, I think. On with the show. Okay, you're listening to Lost in Science, and joining me online today, I have world-renowned climatologist Professor Michael Mann from the University of Pennsylvania. Now, Professor Mann has previously been the lead author of the Intergovernmental Panel on Climate Change, as which he shared part of the Nobel Peace Prize. He is perhaps most famous for the hockey stick graph that shows the rapid increase in global temperatures due to human carbon emissions. Now, next year in 2023, he will be touring Australia and New Zealand to talk about the next steps in combating climate change. And he joins us today to give us a bit of a preview of that. Thanks for joining us, Michael.
Thank you, Chris. It's great to be with you.
Now, you've been working in climate a very long time, I'm sure. How did you yourself first become convinced that human-produced carbon emissions were affecting the global climate?
Yeah, so I've been at it for a few decades now. It's hard to believe, but all the way back in the late 1980s and early 1990s, I was doing my PhD originally in physics, and then I decided to actually switch into the Department of Geology and Geophysics at Yale University because I was interested in applying the physics and math that I had learned to work on sort of a big picture problem. And at the time, one of the big picture problems left to solve was modeling Earth's climate system. So it seemed like a great physics problem to me. That's how I got into it. And one thing sort of led to another. Eventually, we ended up analyzing what are known as proxy records, like tree rings and corals and ice cores, to literally reconstruct the past changes in climate to provide a context for the warming that we've seen. And honestly, both my PhD advisor and I, at the time, were sort of skeptics. Back in the late 1980s, the early 1990s, there wasn't yet a clear consensus that the signal, the warming that we were seeing, had risen above what we might just consider as sort of the noise, the level of natural variability. Maybe the warming that we had seen was just part of some natural oscillation. And so that's sort of how we came at the problem. And it was in part the work that we did analyzing these paleoclimate data that led us to the conclusion that the recent warming really is unusual, unprecedented, as far back as we can go. And that, by implication, means that there's probably not a coincidence that the warming coincides with fossil fuel burning, the Industrial Revolution, the increase in the concentration of so-called greenhouse gases in the atmosphere due to human activity. So you might say that I sort of started out a skeptic, and by the mid-1990s, in part because of my own work, but also because of all of the other lines of evidence that were sort of coming to the surface, I became convinced, as did my PhD advisor at the time, that human-caused warming was here, that we could indeed now see the signal of human-caused warming of the planet emerging from the noise of natural climate variability.
Okay, great. Now that resulted in this hockey stick graph we talked about. Now, I should just point out that in Australia, we play field hockey more rather than ice hockey, and the field hockey stick has kind of a curved end. But yeah, the hockey stick graph shows global temperatures pretty constant for over about 1,000 years or so, and then a sharp uptick in the last century, thereabouts. Do you think that people accept these results today, or are you still seeing a lot of skepticism?
Yeah, and I should mention, when I was down in Australia a couple of years ago, I actually went to a hockey rink, a skating rink in Sydney, because there was a team that was sort of recording a video about climate change, and they wanted to drive home the hockey analogy. So they actually had hockey players out on the skating rink to sort of reenact a game of hockey for an Australian audience. But you're right, the hockey stick is perhaps a little less familiar in the form that we think of it here in the United States, down in Australia. But whether you want to call it a field hockey stick or a hockey stick, or frankly, a scythe, because if you look at the latest reconstructions that go back even further, there's a much longer handle, and it's sort of curved, but there is the unmistakable blade of the hockey stick, the warming that we've seen over the past century, which is unprecedented as far back as scientists can go now. In the most recent report of the UN Intergovernmental Panel on Climate Change, or IPCC, they presented a much longer hockey stick, which is to say that we can now go back further, and as far back as we can go now, thousands of years, there is no precedent for the abrupt warming of the past century, and the blade itself has gotten longer because 2 decades ago, in the late
course,
1990s, it wasn't as warm as it is now. So the blade is getting longer. The handle has been extended further back. And so it is now the consensus based on dozens of studies that the warming that we're seeing now is unprecedented. As far back as we can go, that rate of warming has no precedent in the past that we can find. And we know that it can't be explained by, say, chance events or natural variability. It's due to fossil fuel burning. It's due to us.
I suppose the other side of it is, when people have accepted the reality of climate change, we're seeing now, I guess, a move to, I suppose, defeatist attitudes, you could call it. I mean, we've had the recent COP27 climate conference in Egypt, where the headline achievement was not so much increased emission reduction or plans to phase out fossil fuel, but like a climate compensation fund, basically saying we're causing the damage, we'll just pay for it, we're not going to try and change it. What do you think of this sort of defeatist attitudes?
Yeah, this was one of the central topics in my last book, The New Climate War, much of which I actually wrote when I was on sabbatical in Australia during the Black Summer. I happened to be there in Sydney to witness that devastation, and it impacted the way that I wrote, the way that I viewed the climate crisis myself. It really impacted me. And one of the things that I talked about was, as denial becomes untenable, and if you were in Australia, that summer, you couldn't deny climate change any longer. Even the Murdoch media empire in Australia was backing away from their denial because it was just clear to the person on the street that not only is climate change real, but we're seeing the consequences. We were seeing the consequences that summer in the form of unprecedented heat and drought and bushfires that blanketed the continent. And so it can't be denied anymore. But, the vested interests, polluters, the fossil fuel industry, they haven't given up. And so they've really shifted their tactics away from denial and towards other, tactics that are still aimed at keeping the status quo, that are still aimed at preventing us from moving away from fossil fuels. And that includes deflection and division, but it includes despair mongering and doom mongering. Ironically, if they can convince us it's too late to do anything about the problem, then it potentially leads us down the same path of inaction as outright denial. And so this is one of the real obstacles now. Doomism, this idea that it's too late to do anything. And you're absolutely right. There were aspects of the most recent climate conference of the party, COP27, as it's called, the UN climate conference in Sharm el-Sheikh just weeks ago. There was some disappointment. Now, let's be clear that it was great to actually have, at COP27, an Australian government that at least was working with the rest of the world, that recognizes the importance to lead on climate. And the Australian climate negotiator, Christopher Bowen, I think is his name, actually led a task force on what's known as harm and damage. But the fact that a lot of countries, especially the developing world, has already sort of experienced the devastating impacts of climate change. They don't have the infrastructure that we have in the industrial world to sort of protect themselves against the floods and the heat waves and the wildfires and the superstorms. And so they're feeling many of the worst consequences. And so there's this fund, loss and damage fund, to help developing countries deal with the impacts that they're already suffering through. And Australia, Christopher Bowen, the climate negotiator, actually led that effort. And so Australia played a really important role with that. But you're right, it's sort of a double-edged sword, isn't it? Because the more concessions we make that we need to sort of adapt to the harm and suffering that we're experiencing, there's the possibility that distracts from the greater task, which is to prevent additional harm. And there's no question we need to adapt to those impacts that are now unavoidable, but we have to prevent those impacts that are still preventable, because if we continue with business as usual, burning of fossil fuels and warming of the planet, we will exceed our adaptive capacity. Australians understand that increasingly. That continent with the floods and the wildfires, we can imagine an unlivable world where extreme weather events make it uninsurable to build a home in large parts of the country. So we have to recognize that, yes, it's important to instill resilience, to adapt to the impacts we're already feeling, and especially to help the developing world, the global south, who had the least role in creating the problem and are suffering the greatest consequences, to provide resources to them to deal with that. That's all important. And that was one of the breakthroughs at COP27. But the breakthrough we didn't see was a ratcheting up of the commitments by the United States, by Australia, and all the other countries, our commitments to decarbonize our economies, to move more rapidly away from fossil fuel burning. So there's still a lot of work to be done there.
You talked about coming over here during the Black Summer bushfires. Now, this year, we, of course, have seen record floods, like constant floods in some parts of the country, it feels like. How do people reconcile these two, like, seemingly opposite effects of climate change?
Yeah, there's actually a sequence that I show in my standard climate change public lecture from Australia, from New South Wales, in fact, because it's the contrast between the devastating wildfires that we saw during the Black Summer, and then, a year and a half later, the devastating floods. You probably have seen that video of a house floating down a river, just sort of remarkable fluctuations from one extreme to the next. And the critics will say, well, you're climate scientists, you can't make up your mind. Which is it? Is it the heat and the drought and the wildfires, or is it the floods? The answer is it's both. We actually expect greater extremes at both ends of the hydrological spectrum for a basic reason. When it's hotter and drier, you get worse drought, and summers in general are getting hotter and drier. So you get the worst droughts, and the heat combines, with that drought, and you get the bushfires. But when you get those winter rains, and in California, we will still get those winter rains, even though we have devastating wildfires in the summer. In Australia, we will still get those winter rains. And when those winter rains come, so when the conditions in the atmosphere are conducive to getting rainfall, you get more of it because the atmosphere is warmer, it can hold more moisture. So if you get that sort of upward motion that allows you to produce rainfall, you're going to get more of it. So a warmer atmosphere, when it is raining, produces more rainfall, more of those flooding rains. And so there isn't a contradiction. It's actually the same basic physics that describes the profound droughts that we see in summer and the extreme flooding that we see in winter in many of those same regions.
That's great. Yeah. As a physicist myself, I like to hear it attributed to basic physics.
Yeah, no, we have that in common. And anytime you can bring it, back to basic physics, you feel like you're on a more fundamental footing. Absolutely.
Yeah. And look, you talked about the new attitude from the Australian government, but then as you pointed out, we're not necessarily seeing that translate into the concrete actions, I suppose, that many people had hoped for. So I know we've got limited time here. What do you see as the main things that need to be done, the main actions that the world needs to take?
Yeah, well, let's just say, if the baseline for comparison is, Scott Morrison and the coalition government, then almost anything is going to look like a move in the right direction on climate. But let's give, the Albanese government some credit, and Parliament as well, that has passed, a pretty substantial climate legislation to lower carbon emissions by 43% by 2030. That's a substantial commitment. And so Australians can sort of not do a victory lap, but take some solace from the fact that there is some meaningful progress. But it's one thing to state a goal like that we're going to reduce carbon emissions 43%, in 8 years. It's something else to actually follow through and do it. And so we need to see policies now that will actually implement, incentives for renewable energy, de-incentivizing fossil fuel energy, not providing support for additional fossil fuel infrastructure, not continuing to fund fossil fuel extraction in other countries. These are things that, for example, Australia hasn't committed to and the United States hasn't committed to, and we need to see them happen if we're going to make good on these commitments that we are making.
That is some excellent points. What about the individuals? I know that basically it's the responsibility of the big polluters and governments, but for individuals, is mostly at the ballot box that we have the power to do anything, or is there any other actions that we can take?
Yeah, that's where I think that we in the United States have something to learn from Australia. Some months ago, actually, co-authored a commentary with former Prime Minister Malcolm Turnbull in The Guardian about that monumental election in Australia, the teal independence that rose to the fore, and where we saw, a coalition of labor and independents win back the government and win back the government on a climate agenda. I mean, that election was a referendum on climate. And despite all of the misinformation promoted by, the Murdoch media in Australia, and I witnessed that when I was down under, there's so much misinformation being put out there by them. But the Australian people were remarkably resilient to that disinformation campaign that was being waged against them. And they did vote for a climate-forward government. And one of the lessons that I think we can take away here in the United States is how important it is to have what we call ranked choice voting, where you can indicate a preference for a first and second place candidate, and through the ranked choice algorithm, the ranked choice approach to voting, it's possible to elect centrists. You get a less polarized electorate than you get, for example, the United States, where we lack overall ranked choice voting. Although there are certain states like Alaska and Maine in the U.S. where we have ranked choice voting now, and what you see is a tendency for voters to elect centrists who can reach across the aisle, as we say, that can find common ground and pass common sense legislation. And so I think that was a critical thing in Australia that allowed those teal independents in particular to win a number of critical seats and provide that majority support for climate action that we now have in the Australian government. That's sort of what we need to try to emulate here in the United States. And I think that there will be a move towards ranked choice voting. And I hope, that we will give our friends down under credit for having inspired us to move in that direction.
Yeah, that is, I guess, a promising way to look at it. Look, I could ask you many, many more questions, but we're out of time. But fortunately, as I said, you are coming to Australia and New Zealand next year to discuss a lot of these ideas and what can be done about climate change. I believe it is May and June you will be touring New Zealand and Australia. Tickets on sale at thinkinc.org.au. That's thinkinc.org.au. And yeah, look, we hope to see you again here and hear more from you.
Thanks so much, Chris. I'll tell you, Australia now is really a second home to me. I made so many good friends down there, and I just sort of feel like, I'm part Australian now. I can't wait to get back there and to see folks again and to be part of that conversation that we started really during the Black Summer when I was first down there.
Yeah, well, we look forward to seeing you too. Thanks for joining us, Professor Michael Mann.
Thanks so much, Chris.
I think we're lost.
We're not lost.
Not even any short-range radio signals yet?
Except for a single, very powerful radio emission.
Of course, a transmitter of that sort isn't exactly standard equipment.
Science and technology must be absolutely mind-boggling.
Of course, it's mostly on the theoretical side.
Well, so far.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
The 5th of December each year is designated as World Soil Day by the United Nations, and the theme for this year highlights the importance of this resource that most people probably don't think about all that often. The theme for the year is Soils Where Food Begins, and around 95% of all the food we eat comes from plants growing in soil. So it's a pretty important aspect of life to understand, really. Now, if we're looking at soil, as I said in the intro, we try not to talk about soil and use the word dirt interchangeably. You get dirt under your fingernails, you get dirt behind your ears. You don't get dirt in the ground. When it's in the ground, it's called soil. So the soil itself is a loose layer of mainly mineral particles that covers most of the land masses in the world.
What about when you say I've soiled myself?
That's a different kind of soil too.
Oh, okay.
Yeah. So the soil layer covers most of the land masses in the world, except where there's rock at the surface. So the particles of soil that we consider soil are just basically tiny bits of weathered rock. And there's also a bit of organic matter in there, and there's living organisms in there, and there's all sorts of things going on as well. But the soil particles are divided into categories based on their size. So sand is the largest particles that are classified as soil. So if it's any bigger than 2 millimeters, it's no longer sand and it's no longer soil. It's basically, we call that gravel. But if it's smaller than 2 millimeters, we consider it sand. Now, below sand, you've got even smaller soil particles. So the next size down from sand is silt, which are particles that are between 0.02 millimeters and 0.002 millimeters. So we're getting down very small.
So we're going by orders of magnitude here, essentially, aren't we?
Yeah, basically. And so anything below 0.002 millimeters is classified as clay. So you've got sand, silt, and clay as they break down. Now, there's no bottom limit on this. So anything smaller than 0.002 is clay, but that could be very, very tiny particles. And basically, an individual clay particle is probably invisible to the naked eye. You could not possibly see it.
But so the silt is the good stuff. Is this what you're saying?
It varies. So most of the soils around have a mixture of these three different particle sizes. So the particles themselves are made of all sorts of different things. The classification's purely based on size. So you can't say, oh, that's sand and it's always made of the same stuff. It's often made of silica, which is an element, but the size is the important thing, not the material that it's made of. So you can get clays made of different things, you can get silts made of different things as well, and sand as well. But the classification of the particle sizes is what we call soil texture, and that is actually very important because it tells us a lot about how the soil behaves. So, as I said, most soils have a mix of particle sizes. They have some sand and some silt and some clay, and different proportions of those particle sizes give us different soil textures, which we have names for. So there's 16 soil texture classes that we use in Australia, and you might have heard people talk about a heavy clay soil or a sandy loam soil. They are the kind of descriptive titles that we give these texture classes. So it's a little bit odd, and I said that we use 16 soil classes or texture classes in Australia. We do have a little bit of a different approach to soil science in Australia because our soils are quite different in Australia to where a lot of older research took place. So a lot of the early research in soil science was done in the Northern Hemisphere. Now, in large areas of the Northern Hemisphere, the soils are only about 12,000 years old, which seems a pretty weird thing to think about, that the soil can only be 12,000 years old. But in the Northern Hemisphere in the Ice Age, there was massive glaciers that rolled across the landscape and basically pushed all the old soil into the sea.
Oh, we discussed this just last week, the end of the Ice Age around 12,000 years ago, yeah.
Yeah. So as the glaciers receded, they ground the rock underneath them and created new soils as they receded back after the end of the Ice Age. So they've got very, very new soils in large parts of the Northern Hemisphere. In Australia, we've got soils that are often millions of years old because we didn't get that Ice Age. We didn't get that glacial formation. We didn't, so the soils that we have in Australia have been there for millions of years, not thousands of years, which is what they have in Europe and parts of North America and in Asia as well. So the early attempts at European-style agriculture were not very successful because they were so used to having these, fresh soils, I suppose, with high nutrient levels. They hadn't been weathered very much. And so when they tried to grow crops and get European-style plants to grow in Australia, they were very unsuccessful until the advent of modern fertilisers, which they introduced in the 20th century. So we had pretty low productivity in Australia until those basically chemical fertilisers were introduced into the agricultural systems. So as far as it goes, soil in general has to be able to hold onto plant nutrients. So all the nutrients the plant needs, it has to absorb from the soil. There's 18 essential elements plants require for growth, and 15 of them come from the soil. They have to absorb them through their roots from the soil. Oxygen, carbon, and hydrogen, they don't absorb from the soil. They actually get that from air, which is where the carbon comes from carbon dioxide, and from water. So the hydrogen and the oxygen in the water, and the oxygen and the carbon dioxide.
And that's most of the bulk of the plant is made out of those elements.
Pretty much. And it's also, it's the building blocks of sugar. CHO is the basis of carbohydrates, and that is what plants basically do. They turn energy from the sun into sugars, which provides energy for every other living thing on Earth, pretty much, with the exception of some bacteria that live on deep sea vents and things like that. But so the plants have to absorb these nutrients from the soil, and plant nutrients get held in the soil. They get absorbed onto soil particles, so they basically stick. It's got to do with electrical charges, and there's all sorts of other aspects to it. But basically, the higher the surface area in the soil, the more nutrients it can hold onto, which kind of makes sense. There's got to be space on the soil surface for these nutrients to stick. So the difference between different soil types, the difference between sandy soils and clay soils and the amount of surface area is massive. And it's quite mind-blowing to consider how different they are. So a gram of sand, so you've got a range in sand particle sizes from coarse, very coarse sand, which is very large particles, to fine sand. But if you have a gram of sand, will have a surface area somewhere between 1 square centimetre and 100 square centimetres.
Wow.
In total, depending how coarse it is. But if you look at clays can have a surface area in a gram of clay between 5 and 750 square metres.
Oh, okay. Huge difference.
So there's such a massive difference in the surface area because of the particle sizes. And it's mind-blowing to think how much surface area there can be in basically a spoonful of soil. It's quite astounding. Look, there is a huge amount of science around soils, and some of my research myself was actually looking into soils over the years. But it is a very important thing. It's one of the earliest sort of scientific projects that was established when people settled Australia, and the surveyors would go out and they'd be looking for places to farm where the soils were appropriate and all that sort of thing. So it is a very established science. But the CSIRO are, as I said, in the process of launching a website to provide important soil data, and the website's called the Australian National Soil Information System, or ANSYS. They're going to put this up. The website's already up, so you can go and have a look at it. There's some functions on it that aren't actually online yet, so they're going to be interactive maps where you can basically put in a location and find out what the soil's like, and explanations of what all of that actually means for for using the soil, for managing the soil, to try and improve it. And this is the reason why there is a World Soil Day, is because soil is such an important resource, but we're actually not managing it in a very sustainable way. So we have to figure out how we can improve the soils we do use and retain them and stop them from degrading over time. Because if we just pump them full of fertilizer and keep harvesting the food, it's gonna kill off some of the other functions of the soil. So this website is supposed to be set up to try and educate people and give them the information they need to make better decisions about looking after the soil. So you can have a look at the website. As I said, it's the ANSYS, ANSIS. If you just Google that, you should be able to find it. The CSIRO have been promoting it quite heavily as well on social media if you follow them. But there is some content already up there. There's a whole lot of stuff that's coming early next year. So if you wait a couple of weeks, it'll probably have even more soily goodness on there for you to enjoy.
And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook, we're Lost in Science on 3CR, or on Twitter, where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now. We're the same time every week when we all get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.